All right, so you spend all this time building a machine learning model. Now what? How do you actually know if it's any good? It's not as simple as getting a grade on a test, and believe me, getting this part wrong can have some pretty huge consequences. So let's get into it.
Let's just imagine for a second you've built an AI to predict house prices. You run a test, and for one house, it's off by $20,000. So is that a success or a complete failure? The answer, as you've probably guessed, is, well, it depends. And that's exactly what we're going to unpack today.
You see, when you're grading an AI that's predicting something on a scale, like a price or a temperature or maybe a sales forecast, it's just not a simple pass or fail situation. You need a whole toolkit of different metrics, and each one tells you something really unique and important about how your model is doing.
Okay, so let's start with the most basic question of all. When the model gets something wrong, how wrong is it? We're going to look at the core metrics that are designed specifically to measure the size of a model's prediction errors.
First up is something called mean absolute error, or MAE for short. Honestly, this is the most straightforward way to measure error. You just look at the difference between every single prediction and the real value. You take the absolute value of that error, so a negative error doesn't cancel out a positive one, and then you just average them all up. Simple as that. It tells you, on average, just how far off you are.
So let's go back to our house price example. If your model has a mean absolute error of $20,000, what's that really telling you? It means that on average, your predictions are either $20,000 too high or $20,000 too low. It gives you a really clear, easy-to-understand number in the original units, in this case, dollars.
Now, MA is fantastic for its simplicity, but it does treat all errors the same. A huge $100,000 error is just seen as 5 times worse than that $20,000 error. But in the real world, what if a massive mistake is way more than 5 times as bad? What if it's an absolute catastrophe for your business?
And that's where mean squared error, or MSE, comes in. The key difference is right there in the name, squared. Instead of just taking the absolute value, MSE squares each error before it finds the average. And just think about the effect of that for a second. A small error, like 2, becomes 4, but a large error, like 100, just balloons to 10,000. This means MSE comes down really, really hard on those big mistakes.
So how do you pick between them, MAE or MSE? It really just comes down to this. If you want a simple, intuitive metric where every dollar of error is treated the same, MAE is your best friend. But if a few huge errors could totally sink your project and you need a model that avoids them at all costs, then MSE is the metric you've got to keep your eye on.
There's just one little catch with MSE. Because you squared the errors, the final number is in, well, squared units, like dollars squared, which doesn't really make any sense, right? The solution is super simple. Root mean squared error, or RMSE. You just take the square root of the MSE, and this gives you the best of both worlds. It still heavily punishes those big errors, but the final number is back in the original units, like dollars, which makes it way more interpretable.
Okay, so we've got a great toolkit for measuring how wrong a model is. But that's really only half the story, isn't it? Now we need to flip the script and ask, how much is the model getting right? We're shifting gears now from just measuring error to really understanding our model's explanatory power.
And that's where R squared comes in. It's a value that's always between 0 and 1, and it tells you what percentage of the changes in your target variable, let's say spending habits, can actually be explained by your input variables, like a person's income. A higher R squared just means your model is doing a better job of finding the real patterns in the data.
For instance, let's say you build a model to predict spending habits based on income, and you get an R squared of 0.8. So what does that actually mean? It means that 80% of the variation in why some people spend a lot and some spend a little can be explained by their income. That other 20%? Well, that's due to everything else your model can't see, things like their age, where they live, or just their personal preferences.
So far, we've been pretty focused on the math. But a model that's mathematically perfect is completely useless if it's too slow, costs too much to run, or if the people using it just hate it. We also have to measure performance out there in the real world.
And that brings us to these crucial business metrics. We have to ask, is our model fast enough for our users? That's average response time. Is this whole project actually worth the cost? That's return on investment, or ROI. And maybe the most important question of all, do people who use it actually like it? That's where customer satisfaction, or CSAT, comes into play.
Now, here's a little pro tip, especially for anyone out there who's studying this for an exam. It is so important to know the difference between these metrics. For example, if a question asks you about runtime efficiency, the answer is going to be average response time.
CSAT measures user happiness, not how fast the code runs. Knowing that little distinction is absolutely key.
So we have covered a lot of ground here. Error metrics, explanatory power, business value. The single most important thing to take away from all this is simple. There is no single best metric. The right one always depends on what you are trying to achieve with your project.
So let's do a quick recap. Use MAE when you just need a simple, interpretable error average. Turn to MSE or RMSE when you absolutely cannot afford big mistakes. Use R² when your main goal is to understand how much your inputs are actually influencing the output. And definitely use ROI to prove the model's financial worth to the people signing the checks. Your goal defines your grade.
And I'll leave you with this final thought. If you're building an AI not for house prices, but to help with medical diagnoses, which metric do you think matters more? A low mean squared error, which means you heavily penalize any major misdiagnoses? Or a high R², meaning you deeply understand the factors that are causing the disease? The answer could literally be a matter of life and death. Thanks for watching.